I'll describe how to use an interactive simulation that shows the TXY and XY diagrams for a binary mixture that's fed to a flash drum. And so the location simulation is given by this link. A snapshot of the simulation shows that we have both XY diagrams and TXY diagrams, and we can see them both together or we can see individual ones. We can change the liquid to vapor ratio, L over V, and we can change the mole fraction of methanol in the feed, in this case 0.5, which indicates the ZM value of 0.5. The lever rule is indicated by this equation. So liquid flow rate, vapor flow rate leaving the flash drum is just related by the lever rule to these mole fractions. So these mole fractions are also related to the slope of this line on the XY diagram. So this line here, turns out its slope is change in Y, so Ym minus Zm over Xm minus Zm. Well, you'll notice that's just the negative of this value, which means this is therefore the slope is minus L over V. So let's look at this simulation. So as indicated, the slope of this line is minus L over V, and for liquid to vapor ratio 2, so I can change this ratio with the slider. Therefore, change the slope. I can change the mole fraction, which moves the Zm value. And then this insert here shows the mole fractions leaving the flash drum, and that can be seen, of course, from this diagram as I change Zm value. And if I change the L over V and keep Zm the same, then, of course, the temperature is different. So fairly simple mass balances here for a flash drum in order to represent the behavior on a XY diagram.